Welcome to Ask and Learn.
So we take a 10 microfarad capacitor and we charge it to 15 volts and then connect it to a battery, which is 50 volts, and then another capacitor, which has 5 microfarads capacitance. And well, we can figure out the initial charge on this capacitor. I'll say this is C1 and C2. The initial charge, which I'll call little q, is going to be the capacitance times the initial voltage, this number, which is 10 microfarads times 15 volts. That's 150 microcoulombs. And now we can say that the potential across the first capacitor plus the potential across the second capacitor once they're connected has to be 50 volts. And we also know that the charge so they're going to get charged by the battery, and that additional charge that we add is going to be the same for both since they're connected in series. So the first voltage is Q1 over C1 and Q2 over C2. Now, the total charge that they have on them is not going to be the same, just the charge due to the battery. Now, C1 already has a charge on it of 150 microcoulombs because we added that charge beforehand. So the charge on the first capacitor is going to be 150 plus whatever Q we get from the battery. And it's a 10 microfarad capacitor. And the second one initially has no charge on it. So that's just Q divided by 5, and that equals 50. Now we can solve for Q. So I'll multiply by 10. We get 150 plus Q plus 2Q. It's 500. So that's 3Q is 350. So Q equals 116.7 microcoulombs. So now that we have Q, we can figure out each of the voltages. So delta V1, which is the 10 microfarad capacitor, is going to be 150 plus 116.7 divided by 10, which is 26.7 volts. And the voltage across the second capacitor is just the 116.7 divided by the 5 microfarads capacitance, which is 23.3 volts.